The ubiquity of common web cameras, coupled with the capabilities of modern processors, is quickly making gesture-based interaction a realistic input modality for a variety of computing devices and applications. In this video, we focus on one of the most frequently proposed application spaces for this input modality, namely electronic presentations. Presentations are a natural domain for gesture-based input because people naturally gesture at slides when presenting. As such, numerous gesture-based presentation systems have been developed. However, past systems have not been evaluated in real-world settings, and little is known about how well this interaction style would actually fare when used on a day-to-day basis. To address this gap in the research literature, we designed and evaluated Maestro, a gesture-based presentation system. Maestro's design was informed by our observations of how people gesture when giving presentations. We noticed that natural gestures tend to be highly contextualized by the contents of slides. Consequently, Maestro was designed to allow presenters to both navigate their presentations and to interact with the content of their slides using hand gestures. We describe each of these classes in turn, beginning with navigation gestures. In support of presentation navigation, presenters can perform gestures to advance the slideshow. They can also execute gestures to scroll slides and to bring up the slide carousel, which provides random access to any slide in the presentation. Maestro also affords gestural interaction with the actual content of each slide. This capability is unique to Maestro and has not been previously demonstrated by other gesture-based presentation systems in the literature. In Maestro, blocks of text can be highlighted by pointing to them with one hand. Presenters can also selectively enlarge figures that are embedded alongside text and can author slides with expandable bullet hierarchies. Having described Maestro, we now turn to the problem of assessing the viability of using gestures to control presentations. To accomplish this, we deployed Maestro in a classroom setting for 2 weeks. During this time, Maestro replaced PowerPoint as the main presentation system used for lecturing to a class of approximately 100 students. The evaluation revealed that students found lectures presented using Maestro to be more interactive than those presented using PowerPoint or those taught on the blackboard. It also revealed that students responded positively to gestures which interacted with slide content. However, Maestro's presentations were rated by the audience as being less efficient than those using PowerPoint. This was especially true for PowerPoint presentations controlled using a wireless remote. We also found that a gesture-based interface can noticeably alter a presentation in unexpected ways. The interface can limit a presenter's mobility by requiring him to remain near the screen in order to control the presentation. When standing near the projection screen, parts of the display are outside of the presenter's field of view. Consequently, he must step away from the screen in order to view slides in their entirety. This can cause a noticeable break in the flow of the presentation and can give the impression that the presenter is unprepared. Additionally, Maestro's interface encourages presenters to face the screen. As a result, the presenter may miss questions from the audience. Finally, Maestro's reliance on monocular computer vision introduces a so-called no-fly zone. This is a volume of space in which the presenter cannot enter without risking accidentally issuing gesture commands. Notice the constant activity in the slides behind the presenter. In this video, we presented the design and the evaluation of Maestro, a gesture-based presentation system that requires only a standard web camera for input. Maestro allows presenters to use gestures to both navigate the presentation and to interact with slide content. Our study suggests that gestures that interact with content, as opposed to those that enable navigation, best leverage gesture-based input in this context. Our study also illustrates potential side effects of relying exclusively on gestures for presentation control.